Projects 6 and 7 are both about the applications of electronics. This is Project 6. It has 4 circuits, I believe. The first one being this, which is essentially a detector on AC voltage. The idea being the inductor induces a current, which therefore creates a voltage that'll open up the transistor here, which will turn on the LED. The larger your inductor, the more sensitive it will be to the AC currents that are around you. I made quite a long one that was very sensitive. The one in the video is shorter, but will still detect things that are fairly close. As you can see here, this one does have sound. So yeah, you can hear that. You can see in the video here, Darlington pairs were used to increase the sensitivity of it, so the induced current just fully opens up that last one there. You can see as you can see here, as you get closer, this wave is closer, the current does change based on how I hold it, how close I am, stuff like that. I'll yield the next video. There we go. The next thing we're doing is an IR detector, using a PNP transistor here. On this one's fairly straightforward. This one got a TV remote in my hand, just pressing the button, and it detects the stuff. The buzzer's beeping to the code of the that the sending out. And you can see there, actually what happened right here is the LED burnt out as I was recording the video. And you can hear the buzzer getting louder there too. I'm not sure as to quite why it burnt out there. We're not pushing that much current through it. And this is actually the signal that we're getting through the IR. And you can see that it's well clear. This is like the menu button on that TV remote. This is the power on button, actually, for the TV remote. And this is listening a little interesting. I found when I was opening my laptop next to the IR sensor, it buzzed. I found out that my laptop has an IR face reader attached to it, which I do use. I just didn't realize it was IR. And this is the scanning waveform that it uses. This is just one period of it. It does repeat itself. And the next one we got is the dimmer circuit. Basically, if you touch between A and this like here, if you activate touch A, the voltage goes up. Touch B, the voltage goes down. And these are 1.5 megohms on those. You can see a video of this. Touching A, it goes up to 8.2 volts. I do have this set at 9 volts. But that should be a problem for this system anyway. And then as we touch B, it drops itself back down to 1.9 volts. That's what I got it set to. I will say though that I did not in this, whenever I was recording this, I did not have the negative side hooked up to a negative voltage of a negative 9 volts. Whenever I did that, I could get the voltage down to about 500 millivolts, and that would be enough to turn off an LED. Go next. This thing is stickety. And circuit 4. This is probably the most dangerous circuit we've built thus far in this class. That being because I took the wire from an unassembled lab transformer we have, and just sort of hooked up the ends to the breadboard once I plugged it in. See that here. Don't need to listen to me, but you can see there's the thing right there. I had the ends of it are over here, out of the way, not near anybody or near anything that can conduct electricity for safety reasons. Anyway, large capacitor here to slow down the rate at which the bulb here changes. Diode on the back there to prevent backfeeding. Resistor to limit current draw from everything. See, it slowly goes through, and then whenever you turn it off, it slowly fades out. Turn it on, slowly fades back in, out, in again, and then it'll fade, go through. All right. That's also just me working back and forth, so that whatever it left off at, it'll continue from there again, based on the circuitry and the internals of the LED there. Another thing, used a power strip here so that we're able to control is on or off without just unplugging it from the wall or not. And I believe that may be the last one on that. Yep, that's the last video on that one. All right. Thank you for watching.